Hey everybody, this is Larry. This is day 4 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Mirror reflection. There's a special square room with mirrors on each of the 4 walls. Okay, this one is unique enough that I vaguely remember this, but maybe not. So maybe we'll figure it out. I mean, I think I have some idea. And yeah. And I'm just looking for my drawing thingy because you know, it's coming. I mean, it seems like a very drawing-y thing, right? Just for sake of, easiness, we'll assume that P is less than Q, or yeah, P is less than Q, because then otherwise we'll just swap it. So then that makes our math maybe easier. Let me pull up the drawing thing real quick. But yeah, hope everyone's doing all right. While you're here, hit the subscribe button or whatever. I don't know. So let's see. Okay, so let's say you have something like this, right? Well, with P equals Q, then what happens? If P equals Q, then we hit 1, right? So we return 1. Let's just, okay, I actually forgot to set it on anyway. I should have. But I'm just going to write something like a P is equal to Q, we return 1. There may be other cases, but we can think about it. We'll think about it with the drawing. Okay, so then now, okay. So what if P is not equal to, so let's say so P is equal to Q, that's equal to 1. How do we get 0? Right? How do we get 0? So so there are only really a couple of cases and I'm trying to figure out how that relates with P and Q, because then here another case might be something like, so 2 is the one that's on the thing. But what if you have something like So that would also be 1, right? Can we even hit 0? Oh, well, I mean, I guess we can hit, I think I have a line of code where I swap P and Q, but maybe that's not true. So in the sense that that's how you hit the 0 is if Q is bigger than P, right? So, so then here we have some symmetry thing yeah, maybe, okay. I mean, I'm going to show the code real quick about my modification. If P is greater than Q, then we don't swap, but we return, I think 2 minus self.mirror reflection of Q and P, right? And the idea here is that it's just you flip it. And I think flip it by mapping 0 to 2, 1 to 1, and I think that should be good. I don't think you can, and this is, I guess, a case of enumeration, right? So so P is equal to Q is equal to 1, but they're also clearly another case, right? So they're really only, so now that we assume that P is less than Q, then we and then I kind of messed it up a little bit, but let's say we have P and Q, and P is less than Q, then what happens? Wait, what? Yeah, P is less than Q, right? And Q in that case will be, oh, maybe I'm a little bit confused here, but I thought P and Q is different, but okay, let me think about this for a second. Maybe we don't need that condition. Maybe I'm prematurely. I don't know, you didn't see it, but I just deleted the code. Okay, so P is always the length of the room, so it's always P. So we have we can just do a case analysis. Let's start by that, right? So P is equal to Q, then you go to 1. If P is equal to, so this is also equal to 1. I mean, assuming that the angles are correct, and then you have someone like this, right? So what happens? What does that mean to get it equals to 1, to go to the diagonal? That means that, okay, well, you can draw something like this, right? And I'm drawing right now. Here's my pen. But you can kind of see the pattern, to be honest, a little bit. As we did, oops. So let's say we have P, and then you have something like, okay, this is Q, so Q, right? So Q. And then another thing that you can do, maybe I should put Q for, it's fine, I guess. To get that to that corner, what is it, right? And you could kind of draw this dotted line here, right? Oops, used the wrong draw. And here you can clearly see that, you know, you have Q here, and Q here, assuming the better. So Q, you have 3Q, and then, you know, you could kind of see the, you could kind of see the pattern now, right? Where in the next case, you can imagine that, I'm just changing colors. Then you just have 5, right, or more. 1, 2, and you know, you can assume that these things are the same, or otherwise, you know, it wouldn't bounce that way. And that for each one, and in this case, you can count that they're 5Q. I think that's basically the idea. Is that if, okay, so yeah, so this is P is equal to Q, P is equal to 3Q, P is equal to 5Q, and so forth. So that means that if, you know, P over Q for is equal to odd number, it will go to 2, right? And, oh, sorry, this is 1. And also in the same way, let me just erase this real quick. In the same way, you can kind of construct, you know, like what goes to 2, the one that's in this corner, right? And again, pretending that, you know, I'm drawing perfect angles and so forth, right? So here is, you can say that this is Q, right? This is the Q, and you can also draw a line here to kind of, you know, show that this is Q, which is obvious, but then that is just 2Q. And I think that it doesn't take that much of a generalization to get to even number of Q is 2. So, okay. So let's write this code real quick before I forget it, but should be okay. So basically, if P is greater than Q, and there are probably ways to simplify this code, but that's okay, right? If P is bigger than Q, then we want P over Q and seeing if that's an odd number, right? Is that right? Because what if this is 3 and this is 2, right? Well, if this is 3, this is 2, then you have 1.5. This is 2. What am I saying? I think I have the idea, but I have to figure out what that means, right? Okay. I guess another way to say it, though. Oh, I think I have another. If Q is less than P, then what happens? Let me think about it again. So I think I have the case where if P divides Q directly, then we get what we get. But I guess another thing that we can think about is, okay, let's say it's not perfect, right, anymore. And this is just case analysis, I think. And then you can kind of you could normalize it in a way. But let's say I have something like this, right? And then now it goes then maybe. And here, another way, so you can do it this way, but another way to think about this hitting the top border will be just drawing another box. Okay, I kind of went out of room here. So pretend it is a good box. And then you go do, right? And here, that means that you would reach this corner equivalent, right? And then here, we're trying to figure out, well, what does that mean? Well, it means that we have 2P, and Q, we have 3Q, right? Is equal to 3Q in this case. I don't know if I'm drawing that in a way that makes sense, but in this case we have, let's say this is Q. We draw the same way that we had before, except for now we have 2P going to the top. This is P, this is P, and this is Q, this is Q, this is Q, right? Okay. So then the idea here then is try to figure out, so then now again, for P is greater than Q, we have P over Q is equal to 3 over 2. Yeah. I guess in those cases, then it just always goes back to this corner, because I think the ones where to hit 0. Oh, sorry, this is 1. Sorry, wait. To hit 1, we kind of already went over the conditions of the odd ones, and then to hit 2, it has to be even, and then all the other ones will hit 0 then, right? I think this is right. We might have to do the other one where Q. Oh wait, is Q always less than P? Yeah. Okay. I think I thought. I mean, I misunderstood the problem initially, so I thought that obviously P has to be greater than Q, but initially I thought that I could maybe go this way, and that's why I was like P is greater than Q, because in this case, I just misread the problem, but in this case this is P and this is Q or something like that. I don't know, but so I misread that part. A lot of misreading, but I think this is maybe right. So let's give it a spin. Let's give it a try. I think that's exhaustive in that way. So yeah. So if P mod Q is equal to 0, then if P divided by Q, if this mod 2 is equal to 1, that means we have an odd number, so then we return 1. Otherwise, we return 2, because then that means that if it's even number going into, it will go to the top left corner or equivalent, and then at the very end, else is 0. I think this is maybe right, but I don't know. I'm not confident. It's very easy to, yeah, and then maybe because we get to do it for free, let's just. Yeah, just a lot more test cases, and then maybe we'll run to see if we get it wrong and make a wrong assumption somewhere. Oh, we did make a wrong assumption somewhere. We return a lot of zeros, which is wrong. I'm trying to like make this scroll up, but it seems like I can't really. Okay, so the second to last, so 10, 7, I put 0. Even though it is supposed to be a 2. So I was wrong in that assumption. Okay, let's see, 10 and 7. Let's draw it back to the drawing board. So 10 and 7. I guess I don't really need this thing on the left. Okay, so what does that mean? And let me use a different color. Okay, so maybe I misunderstood the input a little bit. Hang on. Okay, so P is 7, right? Oh, sorry, P is 10 and Q is 7. So let's say it's about 3 7s or something like, 7 10. So it's like right here, right? So this is Q. And here, what does that mean, right? Oh, I think I'm just being silly, maybe. So that means that we can say, if this is Q, that means that we have 10 of these, right? Well, right, let me see if I have an easier example. Okay, I failed on the fourth one. So I could draw it a little bit better. 2, 3, 4, 5, 3. Okay, so this, let's say P is 5, Q is equal to 3. Right, so that means that we have 5 boxes. Again, I ran out of space. Mistakes were made. Because basically what you're trying to do is find the number in which I was just a little bit lazy. I think half of this is still right, but the 0 case is wrong. Because basically what we're trying to do is try to figure out the next number in which it matches up. Okay, so then now, okay, let me think about this. So what is the greatest common numerator or denominator of this, right? That means that we have 15 units, and 15 units, well, yeah, oops, I think we only need, yeah, I think I drew too many, to be honest. I confused myself a little bit, because now, okay, so this is 3, oops, how did that happen? My 3 got like tied together. So okay, so the 3 and the 5, that means that you know that it's going to connect on the 15, because then it's the number in which there's no leftovers, right? So okay, so what does that mean? That means that this is 3. The next time that it's going to come back, it's going to be at 3, 6, 9, right? So 9, right? So 9 is like here-ish. And then 9, the next way it's going to come back is 12, right? And then 12, okay, I really drew this terribly. But I think this is a better way of doing it, so that's my fault. But yeah, so I think that now makes sense. Is it possible to get 0 at all? No, it is, right? Because we just did a case where it's 2 and 3. Okay, but here you can see that at 15 boxes, you know, here it goes Q is equal to 3, and then the next one is 9, and then the next one is, wait, did I mess up again? I think I did the math wrong, that's why. Ooh, yikes. So yeah, this is 3, and then, you know, you draw a midline, this is going to be 6, so this is going to be 9, and then the next one after that is going to be 15, right? Yeah, because now 9 plus 3 is 12, and then 12 to 15. Okay, so in this case, this is going to be 1. And before, I don't know, I just kind of did that if it's not mod is equal to 0. So okay, so that means that we just have to extend these fake boxes. I think I mostly had the idea, but maybe I was a little bit lazy. Can you get But that means that it's going to be either 1 or 0. How do we get, or 1 or 2, how do we get a 0, right? Can we get, oh, I guess not. So the idea behind, oh, so nothing can be 0. That may be why. Well, can it be 0? I mean, it can be 0, but I was going to say, oh, I see. Okay. So basically, because I forgot about my imaging, but this is going to be 0. This is going to be 1. This is going to be 2. Let me use a different color. This is an annoying problem. I feel like I thought I remember this, but clearly I don't, so we're doing it together. But then here, if you do a flip, this is going to, oops, this is going to be 0. And it's never possible to get to here, even though this is the flip of the beginning. Drop my pen. Because that would, of course, require it to go, you know, in order to get to here, we would need to have a line that goes to here, to here, to here. But obviously, in this case, it would be intercepted by 1, right? So yeah, okay. So that means that here, we now count the number of boxes, and we know that the number of boxes is going to be the common denominator of this, and then we just check whether the number of boxes is going to be on here or here. And on this one is going to be 5, this one is going to be 10, and this is going to be 15. So we can kind of figure it out that way. I think there's something like that, and yeah. Okay, I think I have the idea, a little bit better idea now, And let's get started. Even though I spent a while on this one. I think, okay. So then now let's just say boxes is equal to P times Q over GCD of PQ. And this is just the way to get the number of boxes that is the next multiple, right? And then now we go, okay, so boxes over mod Q has to be 0 by definition. So then now we go, okay, okay, let me think about this. So if boxes, so if the number of boxes is even, then we are able to get, no, the number of boxes cannot be even, right? Because if the number of boxes is even, then you have this thing where you reflect. So then now the number of boxes is going to be odd. And then the question is trying to determine whether it goes on the left side or the right side. And then, yeah, so the left side is something similar to this formula, but because that's what we had before, but we just messed up on the 0. Okay. How do we get it on the left side? So it is on the left side if, well, P would have to, or sorry, Q would have to be, or P will have to be a multiple of Q because, okay, yeah, I think that's the case. If P mod Q is equal to 0, then we return 2 because that means by definition it bounces a even number of times. Is that true? No, that's not true. Whoops, what am I doing? No. If it bounces a even number of times, then yeah. So we had it before actually. Except for that, yeah, I think I just didn't write this in a good way. This is still a case analysis, so I was right on the intuition, but the case turns out to be way harder than I think. But yeah, otherwise, this is going to be on the right side. Now it's going to be either 1 or 0. So then now we have to count the number of boxes, and if the number of boxes is even, I said that boxes cannot be even, but I meant the number of boxes cannot be even on the left side. Sorry, yeah. If boxes is equal to even number, then it's going to be 0. Otherwise, we return 1. Okay, let's try again. It's just about articulating these examples in a good way. But again, apparently this is not the good way. Still wrong. Now I'm trying to think whether I did not represent this way or, what am I wrong on? I mean, I'm wrong on the 3-1 example. So the number of boxes is 1, right? In this case, isn't it? 3 times GCD. Do I want GCD? What I want is the LCM, right? So this is the LCM. The LCM is the number of boxes, but that's not true. That's not the number of boxes. Because in this case, if we have 1 and 3, the number of boxes is 1, not 3, right? Oh. Okay, so I have to represent this a little bit better. So the boxes formula is wrong, but the boxes idea is correct. Yeah. Man, this is a medium. Yikes. A lot of negative quotes. But okay, so how do we get the number of boxes? Let's say P is 3, Q is 1. Well, if P is... Oh, and I think I have to do just to if P mod Q is equal to 0 and this. I think I missed the multiple part. The other part is if p mod q is equal to 0. All right, let me just run it real quickly, just in case I missed some other things. Oh, whoops. So I thought box is going to be the most common multiple, but for 1 and 3, p mods q. But yeah, okay, maybe I just have to do something like this. Yeah, because if they mod each other, then it will go to one of these things. But wow, I mean, I'm kind of cheating here because I'm like, trying things, but at least it lasts until that later. 10.7 as well. 10.7. The way that I would have it would have 70 boxes. That's definitely not right. So my boxes is just formula is just wrong in general, because we definitely do not want 70 boxes. I mean, even 10 boxes isn't enough, right? Just by pigeonhole, like 7. Oh, whoops. So this is, I see. So the LCM is equal to this, and then the number of boxes is going to be LCM over Q, because Q is the side, no, over P. Because P is on one side, so the number of boxes is the LCM, and 70 is the length. The LCM is the length that we're trying to get to. Okay. I think I visualized it correctly, but I used the wrong math. So I don't know what to tell you, friends. I was more confident about this one, but clearly still no Gucci. And this I just did as well. Okay. Did I get anything earlier wrong? Oh no. Only one of the last. So 10.7 is wrong. Oh, 10.7 could be a 2. So maybe I'm wrong on some of this. Oh no. So oh yeah, okay. I added this thing, but what I mean is that if boxes is even, then it's either 0 or 2. How do we figure out the 2's? Well, the 2 is if it's on the left side. Wait, what? No, not the 0 part. If number of boxes is even, it's always 0. Okay. If boxes is odd, then now we're trying to figure out how to get to the left side or the right side, right? It's on the left side if Q, if now, okay, the LCM mods or divided by Q. Okay, I think we had the right idea, but again, I assume P is to each side, but then now we have P times whatever to get to the LCM, and then now if we divide it by Q, then we will get the number of bounces that we have, and the number of bounces, if it's even number of bounces, then it is 2. Otherwise, it is odd number of bounces and it's 1. Wow, this is a ridiculous problem. Okay, yeah. I just didn't really articulate it in a good way, to be honest. Really struggled with this one today, and half-hour problem. I don't think this should have been a half-hour problem, but some days you have good days and some days you have bad days. I mean, this is also all of one, depending on how you want to say it, because if you want to say the input size is the number of bits, then this is linear because all these are linear operations and number of bits. But otherwise, linear time, linear space, or constant time, constant space, depending on how you want to define the things. Hopefully we did struggle a lot on this one, and mostly because I just counted stuff wrong, because I think I had most of this, but instead of LCM, I had P in like cases like this too. And on boxes, I just got confused a little bit because I was using the LCM as the number of boxes, but I just forgot to divide it by P. But once I have that, I think this is, because by the time I actually did it at the very end, and you could hopefully see it, I was more confident. So yeah. Anyway, that's all I have for this one. Let me know what you think. hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. Given I solved this twice, I still struggle with this one because this is kind of one of those ad hoc weird ones. But I had the idea mostly right, but I was just off by a little bit today. Anyway, I'm going to do an extra problem as well, so definitely hit me up there. I'll see you later and take care. Bye-bye.